Welcome to the video. I know this is titled Pure Substances and Mixtures. We've already covered pure substances a little bit. This is going to be mixtures and classification and separation. All right, so the objectives for this video is I want you to be able to distinguish between the two different types of mixtures that are present. I want you to be able to classify any piece of matter based on its composition. So, which of the two types of mixtures, or is it an element, or is it a compound? So, one of those four things you should be able to classify. And we'll also go over three methods that you can use to separate mixtures into individual components. And based on what you want to do, you figure out which method is most appropriate for a situation. Right? So a mixture, so a pure substance only contains one type of particle, right? So a pure element only contains one type of atom. On the diagram to the left, I have pure elemental gold. 100% of the atoms in that sample are gold atoms. A mixture is when it's not a pure substance, so when you have other things present, right? So I have two other gold samples, 18 karat and 14 karat gold. Carat basically means how many parts out of 24 gold is, right? So 24 karat gold is 24 atoms of gold per 24 overall atoms. So it's 100%. 18 karat gold means that out of every 24 atoms in the sample, 18 of those are going to be gold. The others are going to be some combination of silver and copper and other metals. 14 karat gold, 14 atoms of gold per 24 total atoms, right? And again, silver and copper are the other two predominant things. Now, whenever you have a mixture of metals, a mixture of metals is called an alloy, A-L-L-O-Y, right? So 18 and 14 karat gold are different alloys of gold. Now, one of the key things to keep in mind here is that in a mixture, these different atoms are not connected through covalent bonds. If they were connected through covalent bonds, they'd be molecules, right? So they're each individual things. There are two types of mixtures depending on how they are basically dispersed. The first is called a homogeneous mixture. Homogeneous mixtures have what's called uniform composition, basically meaning that every sample is the same, everything is evenly distributed throughout the sample, and its properties are the same no matter where I take it from. Right? So if I have a beaker, for example, of salt water, if I pull a teaspoon of salt water from the beaker and then I take a second teaspoon of salt water from the beaker, both teaspoons are going to have the exact same properties, mass, density, everything will be exactly the same about them, right? Those are homogeneous mixtures. Another name for a homogeneous mixture is a solution. Homogeneous mixtures are very common, right? You see them all the time. So Kool-Aid, any powdered drink mix, is a homogeneous mixture once you put it in water, right? Everything disperses nicely and evenly. Saline, which is again saltwater solutions. Air is also a homogeneous mixture. In air, the predominant gas in air is nitrogen, 78% nitrogen. It's about 21% oxygen and roughly 1% everything else. The other type of mixture is a heterogeneous mixture. Heterogeneous mixtures have different properties at different places because they don't have uniform composition, which an easy way to think about it is heterogeneous mixtures will tend to have chunks if you look at them on a microscopic level, right? So, for example, if you look at a marble, you have those little streaks running through it. That makes it a heterogeneous mixture because those aren't evenly distributed. One of the better examples is think of a salad. Right, if I were to take two samples of a salad, if I were to take two bowls of salad, would they both have the same number of pieces of lettuce? Would they both have the same number of tomatoes, cucumbers, onion slices, etc.? They wouldn't. And even there, inside that bowl, the onion slices and the tomatoes and the lettuce all have different properties. Right? So that's what makes it heterogeneous. So those are the two different types of mixtures. And I will be expecting you to be able to classify these. Again, use your common sense, use your best judgment. Some of them can be a little bit tricky when you get to it. So here's a helpful little flow chart to figure out whether or not you can, or to help you classify matter. So what we're going to look at first off is the composition uniform? If it's not, it has to be a heterogeneous mixture, right? So if there are a bunch of different things and they're not uniformly distributed, it has to be heterogeneous. If they are, it's either a solution or a homogeneous mixture if it's more than one thing that's uniform, or if it's only one thing that's uniform, it's a pure substance, which is either an element or a compound. Right? So this diagram should hopefully help you figure out how to classify these a little bit.